This video is to help you as you're graphing these absolute value equations. First of all, we did in class just the basic equation for y equals the absolute value of x. We also started talking about functions, so I'm going to go ahead and write it as f of x equals the absolute value of x. Remember, f of x, that's the way you say it. That is the exact same thing as y. These are interchangeable. So I could just cross this out and say y equals the absolute value of x. That's the same thing. I just want you to get used to that new look. And we'll talk about that later in another video as well. But real quick, once you know what absolute value functions look like, you should be able to graph all of these without plotting too many points. But as you know, my favorite point is to always plug in 0. So if you plug in 0 right here, the absolute value of 0 is 0. So there is a point. So I'm going to go ahead and I'm going to come over here and I'm going to graph that 1 point. You can plug in anything you want for your x value, anything, okay? I make this up, so plug in anything. It's called an independent variable. So let's say if I plug in 2, plug it in here to your equation. So what is the absolute value of 2? It's 2. So you can choose what you plug in, but you're forced for your y value what comes out after you plug it in. So since I plugged in a positive 2, let's look what happens when I plug in a negative 2. What is the absolute value of negative 2? 2. Okay, let's try another one. What if I plug in 5? What's the absolute value of 5? 5. What's the absolute value of negative 5? Well, 5. That's plenty of points. That's 1, 2, 3, 4, 5 points. That's plenty to see what this is doing. So I'm going to graph 2, 2. I'm going to graph negative 2, 2. My other point was 5, 5, and I'm so old it's hard to see, but 5, 5 I think is right there. And negative 5, 5 is right here. What you should get is a sharp V. So I'm going to look through my phone and I'm going to try to do this. You guys try to make it as neat as possible, but realize I'm looking for my phone. You should have arrows on the end because it's never ending. And here we go. Let me see if I can do this. Sorry. Should have a kid holding it for me. So it's a little shaky, but I'm looking through my phone. So this is what all absolute value functions look like. Sharp V. Okay? No curves at all. All right, so keep this in mind. I still have, remember this is like y equals the absolute value of x plus 3. We know this looks like a sharp V pointing up. What does that plus 3 make it do? So let's plot a few points and let's look. Now instead of y, I'm going to write f of x because it's the same thing as y. If I put in 0, the absolute value of 0 is 0 plus 3, so I get 3. Let me see if I can clear that up just a little bit. Plug in anything you want. I plugged in a 2 last time, so I'm going to plug in a 3 this time just to be different. The absolute value of 3 is 3. 3 plus 3 is 3. How about if we plug in a negative 3, just to see how it changes? Oh, look at this. How about 3 plus 3 is 6? Okay, plug in a negative 3. The absolute value of negative 3 is 3. 3 plus 3 is 6. Huh. Interesting. Okay, so I'm just going to go ahead and graph that. Here is 0, 3. And here is 3, 6. There's 3, 6. Here's negative 3, 6. Okay. If I plug in like 4, hopefully everybody can see I would get 4 plus 3, I would get 7. If I would plug in negative 4, I would get 4 plus 3 is 7. So there's just a couple extra points. I think in class I told you only had to do 3. I'd probably actually rather you have 5, just so you can be sure. But again, you can see my absolute value function right there. Again, let's see if I can do this. Look at the phone. Make sure you put arrows on it because realize it's going on forever and ever. So there you go. And so look, how does that compare? Here's this one, and it started at 0, 0. This one looks like the same thing, but it went up 3. Huh, very interesting. Okay, so you might look at this one, and when you do number 5 on your worksheet, I want you to think about it, what it does. Here's number 5 on your worksheet. That's number 3. Here's number 5 on your worksheet. Lots of nice little shadows going on here. But first of all, notice you're subtracting 1. So I just want you to think in your head what it might do. And here in a minute, we're going to do one where there's a negative out front. but I like you to try to think about what these graphs look like before you ever plot points. So if you can kind of get a visual, it will really help you on your ACT to be able to pick out the right graph without plotting a single point. Okay, so notice the difference between these two. Here I added 3 and it's the outside. Here I'm going to add 3 and it's on the inside. So what do you think this is going to do? Now, first of all, when it was on the outside, it did a vertical shift up. So if it's on the outside, it goes up 3. What do you think it's going to do if it's on the inside? Well, let's see. So here's my x, here's my y, but I'm going to put an f of x instead. I think on your worksheet you have y's, so you can use y's. Favorite point. If I plug in 0, 0 plus 3 is 3. Absolute value of 3 is 3. I probably would like this point. I'm just kind of looking ahead. Remember, you can plug in anything you want, but if I plug in negative 3 plus 3, I get 0. The absolute value of 0 is 0. And if you want, I mean, go ahead and plug in a positive 3. That would give me 6, which is going to give me 6. What if I plug in a negative 5? Let's just do that for fun. If I plug in a negative 5 and I add 3, I get negative 2. But the absolute value of negative 2 is 2. Okay, so what if I plug in negative 1? Negative 1 plus 3 is 2. The absolute value of 2 is 2. Now, I notice I have how many points here? 1, 2, 3, 4, 5. That should be plenty because I know it's supposed to be a sharp V pointing up. So let's see if I can't find that just from these 5 points I've got. So here's 0, 3. 1, 2, 3. Love that point. Negative 3, 0 is right here. Interesting. 3, 6 is right here. So I can see this right here. Negative 5, 2. Negative 5, 2 is right there. Interesting. Negative 1, 2. Negative 1, 2. Now, if you're not sure, I can kind of see, if you're not sure, plug in something over here. Like if you want to just be careful, why not plug in another one if you're curious? I just pulled this out of the air. I made that number up because I was wanting to know what goes on over here. So I take this negative 8 and I plug it in there and I get negative 5. But the absolute value of negative 5 is positive 5. So I'm just going to go ahead and graph that. And here's negative 8, 5. I think it's right there. That's what I get for looking through my phone. All right, so you can see I do indeed have a sharp V. So there it goes up, and I want these nice and neat. If I can do it this neat, as I talk looking through a phone, you can do this definitely. So look what happened. Remember, here was my original function at 0, 0 pointing up. This one, if you want to call it, this is called the vertex. Notice it was 1, 2, 3. It went to the left 3. So weird. You mean you add 3, you would think it would go to the right 3, but it did the opposite of what you would think, and it went to the left 3. Kind of think about that as you're doing your different problems. For example, when you get ready to do this one, what is that one going to do? Can you think about it before you actually plot the points? Okay, that's what I want you to do. We're learning to think. Okay, what happens when the negative is on the outside? Let's look real quick. So I could put x, y, but again, I'm trying to get you used to the fact that f of x is the same thing as y. Favorite point, if I plug in, that's a 0. That's funny. If I plug in 0, I get 0. A negative 0 is still 0. If I plug in 2, absolute value of 2 is 2, but the negative is going to make it all negative, so I've got a negative 2. And that negative is outside, although this stuff is always positive. My final answer is always going to be negative because he's on the outside. So look, if I plug in negative 2 right here, take the absolute value of negative 2 is 2, but it's going to end up being a negative 2. Okay, so do several points there, but look what I've got. Here's 0, 0. When I plugged in 2, out popped negative 2. When I plugged in negative 2, out plugged negative 2. So you can see I should have this V shooting down. It kind of flipped it over the x-axis. And if you're not sure, plug in a 5 and see what happens, or a 6, or whatever you want to plug in. Absolute value of 5 is 5, but out comes 8, negative 5. So you can see here's 5, negative 5 right here. So obviously if I plug in a negative 5, out pops a negative 5 as well. Okay, you can see it's symmetrical on either side of the y-axis. So again, nice straight lines, no curves at all on an absolute value function. So it looks just like that. So if you see a negative on the outside, like this is, think, okay, it's a sharp V, but it's gonna flip it upside down. So remember, when we talked about number 5, I see that negative on the outside, so I'm like, ooh, I bet he's gonna be upside down. And again, what does that do? I want you to think about that, maybe even write me little notes of, hey, this made it flip upside down, and this made it, what? Did it go up or down or left or right? What did it do? Okay, let's look at this. Here, I've got this going outside, and I'm just going to tell you, it's going to make it go up 3 times as fast. So my graph's going to go up a lot faster than it did, and then we're going to look to see what this does. So again, let's do a little chi chart right here. Favorite point. If I plug in 0, I get 0. 3 times 0 is 0. 0 minus 2 is negative 2. So look, I've already got this point right here. Now, no matter what, this is positive, so I should still have a sharp V. It's just going to be a sharp V that goes up 3 times as fast. And do you remember what he's going to make it do? Let's look. I have to graph these things. I don't want to make them too big, but if I plug in a 2, I get the absolute value of 2 is 2. 3 times 2 is 6. 6 minus 2 is 4. So there's another one. Let's plug in a negative 2. Absolute value of negative 2 is 2. 3 times 2 is 6. 6 minus 2 is 4. Okay. What if if I plug in a 3, I can see I'm going to get a 9. And I don't, okay, I can plug in a 4. Let's try a 4. If I plug in a 4, 4 times 3 is 12. 12 minus 2 is 10. So I can fit that on my graph with no problem. So I'm going to plug in a negative 4. That's still 4. 4 times 3 is 12. 12 minus 2 is 10. So that gives me plenty to graph. So my first point, 0, negative 2. I already got it. 2, 4 is right here. Negative 2, 4 is right here. 4, 10 is right here. Woo! All the way at the top. And negative 4, 10, all the way at the top. So here's what it looks like. Pretend I hit those points, okay? Give me a little grace here since I am looking through my phone. You guys can use a straight edge, a ruler. Okay, so look what happened. I still have my sharp V. Remember my original vertex. I'm going to flip my paper over. Okay, my original vertex. Look how fat he is, and he was at 0, 0. This guy, he's skinnier because he went up 3 times as fast. So he's skinnier. And notice, instead of 0, 0, he went down 2. He went down 2. Isn't that interesting? Okay, last but not least, I just want to do one where it's on the inside. This one's going to actually affect how fat or how wide he is. But let's look. Let's plug in 0 because he's my favorite. Out it's going to pop 0 because 2 times 0 is 0. 3 times 0 is 0. No big deal. Okay, let's plug in 1. If I plug in 1, I'm going to get 2. 2 times 3 is 6. And I'm going to plug in a negative 1. That's going to give me negative 2. But that gives me a positive 2 when I take the absolute value. 2 times 3 is 6. I don't really want to go too much higher than this, but I might try half. I can plug in anything I want. 1/2 of 2 is 1. 1 times 3 is 3. And I'm also going to do a negative 1/2, which you can see is going to be 3. So there is my 5 points, okay? Let's graph that, 0, 0. So you can notice it's probably not going to shift up and down or left and right. 1, 6 is right here. Here's negative 1, 6. Then I did a 1/2, 3. And 1/2, negative 3. Whew, look at how skinny he is. So he's going to look like this. So let me explain to you what this did. And then as you do more, I want you to think about your homework just a little bit. This made him go up 3 times as fast as what he normally would. This makes him half the width. So he's not only going up faster, but he's half as wide. Hopefully they'll give you one on your homework that is a fraction. In the inside, I'm looking real quick to see if they do. Oh, padiddle, they don't. That would be so fun. Maybe I'll have to do that sometime for you. But you enjoy